Hello, everyone. Welcome to the webinar entitled Panorama Non-Invasive Prenatal Screening Test, Revolutionizing Prenatal Care. I am very pleased today to present our speaker, Dr. Susan Gross. Dr. Gross is the Chief Medical Officer of Natera and is Professor of OBGYN, Pediatrics, and Genetics at Albert Einstein College of Medicine in New York. We will have a few moments at the end of the presentation to answer questions. If you have questions throughout the talk, please click on the Q&A tab on the bottom of your screen and you can type a question. We will do our best to get to all questions. With no further ado, Dr. Gross.
Thank you, Melissa, and thank you so much, everyone, for joining us today. As you heard, I am a physician. My background is in obstetrics and gynecology. I also have a second specialty in medical genetics, and I'm hoping through this talk to share with you my enthusiasm and my passion and interest in non-invasive prenatal screening, particularly using Panorama, which is a novel and new approach that solves a lot of the issues that we have seen using other approaches thus far. I am an employee, and as you heard, Chief Medical Officer. The first slide that we're going to look at here really looks a little busy, and that's for a reason. It's to share with you all the different ways we have tried to improve traditional screening that really started now several decades ago. And again, the purpose is not to be able to read all the detail. Many, if not most of you on the call today know very well what we have been doing, whether it was to start in 1983 with AFP alone until today when we have ultrasound as well as other serum markers in the first trimester. But the point of the slide is on the right-hand side. Traditional tests, when we apply this to a large population, in fact, there's a 5% false positive rate. In other words, when we just count circulating molecules, the majority of patients with a positive result are not affected, what we call false positives, and undergo unwanted testing if they do select to have an amniocentesis or a chorionic villus sampling. That is an invasive test that has an inherent risk, and in fact, it was unnecessary in the vast majority, 95% of women who have a positive screen test using old traditional methodologies. The original approach to NIPT really was very good. The original approach, and this is every approach except for Panorama, and I'm going to be stressing that Panorama is unique. Every other way non-invasive testing is done is called the counting methodology. And that's where you look at the total amount of DNA that is circulating in the maternal compartment. And it's very similar to the original NIPT. Again, in the old days, we were counting HCG, and we are still doing it now. It's still the first-line screen in many, if not most places in the world. But using anything but Panorama, you're still counting circulating molecules, and I will show you why. We all recognize this. It's the double helix. This is DNA. And what the traditional non-Panorama methodology does is look at these sequences or pieces of DNA, and we look at those pieces that are from a chromosome we're interested in. So for example, if we're looking at pieces of DNA in the maternal system, you can read the total amount of these pieces, and you can see if the pieces are more than you expect or less than you expect. And here is what this looks like on your computer. Anybody listening in today can actually find the entire human genome now on the computer. And we know that there are 4 base pairs, 4 letters that make up our entire code, as you saw in the previous slide. And we can measure these sequences or these pieces. With the traditional technology, you won't necessarily know every single letter, but you can actually see pieces of DNA. So, for example, a piece of DNA, as I said previously, we may be interested if it comes from chromosome 21. And then what happens next? So you measure basically the total amount of DNA. And if you have a certain number of pieces, and that's usually the number that you see floating around, you're called screen negative. If, on the other hand, you have what appears to be too many pieces from chromosome 21, you're screen positive. And again, this is not unlike what we have always done. If you have a certain amount of chromosome floating around and you make a certain cutoff such that you have more than you expect, you're called screen positive. We compare it to a reference chromosome, as you can see on the left. So if you have more 21, but chromosome 3 appears to be normal amount, or if you have more 13, that is a screen positive test for T13, trisomy 13. And again, you should see very quickly that this is how we've always done it. Now, the reason it works so much better than just counting HCG is that even though HCG does come from placenta, a lot of things can vary your HCG level. What was so important about the NIPT breakthrough is that in this case, you're actually measuring pieces of chromosome from the chromosome you're actually interested in. You're measuring finally what it is you really care about. Panorama, however, uses a very different technology. It does not measure a total amount of DNA pieces. It's a completely new approach, and again, by the end of the discussion, I hope to prove to you that it actually is a superior test, because even though the traditional NIPT tests, all the tests, not Panorama, that use this total DNA approach are in fact very good, they still were left with some very important serious problems. So that Panorama actually addresses. So let's talk about Panorama and how it works and why it's different. So we get to go back to exactly the same slide. This is the double helix. Looks the same. What is the difference? Instead of looking at an entire piece of DNA, Panorama is able to look at the actual base pair. So here you see a T, and that's important. It's a T, and we can tell you that when you look at this slide and you look at these base pairs, it is the base pairs actually that really separate individuals. What do I mean by that? Well, let's go back to the human genome again. And you can see in this slide that there may be a base pair where I am a T, but you're listening to the talk and you're a C. Therefore, you and I cannot be the same person. We must be different. And this is what we mean when we say a genetic fingerprint. Now, the problem, of course, is that I might be a T, and there may be somebody else who's listening in today who's also a T. How would you tell us apart? Thankfully, these changes, which are called single nucleotide polymorphisms, that's where the word SNP comes from, happens every 300 letters, every 300 base pairs. We have 3 billion letters, and every 300 times there's one of these minor changes. And that's actually a wonderful thing. It makes us all different. But also, scientists, geneticists around the globe use this every single day to do genetic science and tell individual organisms apart. And many of us actually are familiar with it as well, because that's how forensics is done. When we need to identify somebody who may be a criminal, we don't use fingerprints in court. this is actually the better way to do it, genetic fingerprinting. And again, the idea being, if you really need to make an important, even life or death decision, you need to be as clear as you can. So SNPs, really, it's the only approach that can tell one individual from another. Unlike total DNA, you want to be able to tell the mother from the pregnancy. The counting methodology, where you measure total DNA with a single hypothesis cutoff, is in fact a black box. You don't know mother from pregnancy. With Panorama, you do. And I just want to make the point here that what we're trying to do is separate out the DNA from the maternal, from the mom, from the mother, from the pregnancy. We say fetal DNA, but as many of you who are listening in are probably aware, it actually derives mostly from the placenta. Thankfully, embryologically, the way we all developed from a zygote, we actually have DNA very similar, almost identical usually, between placenta and the fetus, but not always. And that difference actually will be important in a few slides from now. So what? Can you tell the difference between the mother and the child? You can't in the top picture, and neither can our competitors. And again, Panorama is the only NIPT that can distinguish. And when I say so what, many of you may hear, oh, all the tests are the same. So what that this technology is so exciting and it's different? So what? Does it matter if you can tell the mother from the baby? So the rest of the talk is going to be to prove and to reinforce that it does matter. It matters a great deal. And again, being a physician for decades, taking care of patients, this is the only question I have. Does this affect clinical outcomes and care? And I know people listening in today are listening because they also want to know, does this affect clinical outcome and care? In fact, the case is going to be made that Panorama technology is all about improving safety. And because only Panorama can distinguish mother from baby and from the pregnancy, only Panorama can address causes of what are called discordancy. Discordancy means when the screening test and the outcome are not the same. We know these as false negatives, when the NIPT test is negative but the fetus is born effective, or false positive. The NIPT test was positive but the fetus is born, it is normal. So we actually at this point know the reasons for discordancy. Non-invasive prenatal screening has now been around for years, 2 years or so approximately. However, over that time, we absolutely have come to understand the primary causes of discordancy. And false negatives, that's fetal fraction and triploidy. False positives is maternal aneuploidy, when the mother, not the pregnancy, has the abnormal chromosome complement. Vanishing twins, and this is a statement I made before, but it is important. The placenta is usually the same genotype as the fetus, but not always the case. So let's talk about these a little bit more. The false negatives. This is when the test comes back negative and the fetus has a problem on amniocentesis or is born with a problem. Again, 2 reasons. Fetal fraction is very important, and that's when if you use total counting, not Panorama, but if you use total counting method and the fetal fraction is too low, if it's total DNA, you may not even know if the woman is pregnant. And that, of course, is the paper that was in the White Journal that came out recently, where using counting methodology, non-panorama approach, if the test was sent to laboratory from 2 women who were not pregnant, and if you use a counting methodology, the read from the laboratory was 46XX, normal female, which of course now should make sense. If you can't tell if the difference between the pregnancy and the mother, you'll just read the total amount of DNA and it's normal. Triploidy is very important. Professor Nicolaides published in Fetal Diagnosis and Therapy in 2013 that if you use SNPs, you can detect triploidy. Now, triploidy is the situation where there's a complete extra set of chromosomes. So normal is 46 count. You can have an extra set of 23 chromosomes. All the chromosomes have 3 copies. In Down syndrome, only chromosome 21 has 3 copies. Triploidy, all the chromosomes have an extra copy. And if you remember, when you do total DNA, the way it's done is that you compare the chromosome you're interested in, for example, 21, to another chromosome, for example, chromosome 3. Well, if chromosome 3 is also has 3 copies, everything just looks normal. You have no comparison. You have no reference standard. SNPs, as you can see, distinguishes sets of chromosomes, and therefore we can figure out and detect that there's an extra set of chromosomes here. There's an issue. Those are the false negatives. The false positives are truly very important. If you are using a non-SNP, non-panorama test, there are 3 causes when you use total DNA. What if it is the mother who has the issue? Again, it's total DNA. You don't know who it is. Is it the pregnancy? Is it the mother? The additional fetus, especially vanishing twin, and the placenta does not adequately reflect the fetus, which is our biology. The last bullet, and I'll repeat this again later, but is biology. The placenta and the fetus may not match. The top 2 bullets, however, are particular to total DNA methodology. If you do not use SNPs, you can have false positives based on these 2 points, and let's break them down and talk about them in more detail. What if it is the mother, not the pregnancy, not the fetus with the abnormal chromosomes? This is this actually comes from the Futch follow-up paper, and this is Verify, and currently with Illumina. And what they found in their follow-up paper was a very, very important finding, and it is the report of a malignancy in the mother. In cancer, unfortunately, as we know, the tumor can have very unusual chromosome findings. It is part of cancer biology, and if those pieces of DNA break off and float around in the maternal system, it will be read by a non-SNP test. So, for example, if the tumor has extra pieces of 13, it will look like trisomy 13. In the case of this paper, it was a more complex karyotype, and it is published, very important, very interesting paper, but it's floating around in the maternal system. And there was no way to know it was maternal and that it was not the pregnancy. And in fact, in the Futch paper, there's an excellent discussion about false positives when you use counting methodology, and there is mention that it's one of the reasons when you talk to a patient about a false positive that it may be related to malignancy. These are rare. Most of the cases reported seem to be more advanced. However, this is a very difficult decision for a physician to make, whether or not to discuss malignancy with a patient if they get back a positive result using an NIPT with counting methodology. Another very important situation, which is more common, is in the case of the X chromosome, sex chromosome aneuploidy. This is a study that was done where they looked at all the sex chromosome aneuploidy results, and they found a very important finding. Using counting methodology, in 8.6% of the cases of sex chromosome aneuploidy, it was not the pregnancy at all. The mother had sex chromosome aneuploidy 8.6% of the time. And in fact, it's common enough that you can see lower down on the slide in the conclusion section, in the abstract, it says the relatively high frequency of maternal mosaicism, again, it's the mother with the sex chromosome aneuploidy, warrants mandatory white blood cell testing. Now, as you understand, if you use Panorama or SNPs, we must know the maternal background in order to distinguish the pregnancy DNA. However, if it's total, you really don't know. So therefore, with sex chromosome aneuploidy, there are providers all over the world who are put into a position of having to tell the mother, we don't know if you're the one with the issue, and actually offering, like it promotes strongly in this paper, the necessity of offering chromosome testing to the mother. Now, first of all, the mother really wanted to test for the pregnancy. She didn't want to test for herself, and she's obviously healthy enough to be there because she's pregnant. So this is overall a healthy population. And the reason that that number is so high, the 8.6%, is that these women are actually, as I said, they're normal. They're healthy. One of the most interesting things in human biology is that as women age, their X chromosome start to drop out. So in a percentage of cells, instead of being 46XX, it's 45X. That is a Turner syndrome mosaic. And usually labs will read out low-level Turner mosaicism as 46XX as normal. So again, using total DNA methodology, you risk labeling very healthy women as low-level Turner mosaics, which is actually an unfortunate thing. And here you see the graph, very important graph here that shows as you age, as a woman ages, she has increasingly higher percent of cells where the X chromosome will actually be absent. However, these women, by and large, are healthy. So we've demonstrated that if the mother and not the fetus has an abnormal chromosome, total DNA will pick it up, and it will cause additional issues and problems in the office that could have been avoided if you'd known they were mother and not from the pregnancy. The additional fetus, however, is truly coming to light as a very important issue. If you use total DNA, what if there's a vanishing twin? How will you know what you are picking up in the maternal compartment, whether it's coming from the surviving twin or the vanishing twin? There is no way to know if you do not use Panorama. Again, this is from the Verify Illumina process, the Futch follow-up paper. And again, very helpful data for us, because when they looked using non-SNP, what they found is 15% of false positives related to vanishing twin. This is not a rare cause of false positives, 15%. Here's a paper from Maternity 21, Sequenom, also very good paper that helps demonstrate this phenomenon yet again. 3 false positives for trisomy 21. One of them was the vanishing twin. That's a third of cases are vanishing twin. And of course, this makes sense. If the surviving twin is a normal female, but the vanishing twin is a male with Down syndrome, you will pick up the extra 21 and the Y chromosome in the maternal system. and it will be reported out possibly as a male, or it can be reported out as trisomy 21 when in fact at birth or amniocentesis it will be a normal female. So again, to reiterate, it is not that the initial counting method was not a good test. It really was much better than anything we had before, but now I'm going to show you our literature that Panorama is designed to prevent a lot of the, or a better way of saying it is those two particular issues as well as false negatives, but certainly the issues we just discussed. Panorama, by being able to distinguish, addresses these problems. So this is a recent paper, and just demonstrating very well that Panorama can detect extra haplotypes and prevent false positives from vanishing twins. This is in the Gray Journal. It is available to all online. And the test is so good that Panorama, out of 100 times, 96 out of 100 times, 96% of the time, Panorama can identify an extra set of chromosomes. So if we say that we think there's something else in the pregnancy here besides 46 chromosomes, we will get that right 96 out of 100 times. And therefore, we are able to prevent the false positive situation for vanishing twin that you will see if you use total DNA. It works so well that in the Gray Journal, in the conclusion, we were able to state, and I'm going to just read it straight off the conclusion section because it is so clear and so important. The ability of this method to identify additional fetal haplotypes is expected to result in fewer false positive calls and prevent incorrect fetal sex calls. So let's review the causes of false positives. The mother has an abnormal chromosome number, and this can happen in 8.6% of counting method non-SNP cases. Panorama, not a problem. Vanishing twin, 15 to a third of false positive calls in the literature using counting, non-SNP. In Panorama, not a problem. The last reason for false positives, placental chromosomes do not match the fetus, which is CPM, or confined placental mosaicism. It is biological fact. It is the reason that non-invasive prenatal screening can never be diagnostic, like an amniocentesis, where you're actually getting fetal cells. But if that's the case, if that affects all NIPT tests, it's even more important for us as providers to ensure that we minimize the two reasons that we actually can address, and we do address with Panorama. Now let me show you the literature that makes the case and is peer review that Panorama actually does have a superior false positive rate. So this is our validation study by Eugene Pergament. This was in the Green Journal. And this is our laboratory validation. And in this slide, what I'm going to address here is specificity. We had a p-value that was highly significant, and specificity, as we know, equals 1 minus the false positive rate. If you have the specificity, you have the false positive rate, and vice versa, 0.009. Now, the other point on that slide is how Panorama is truly excellent at calling gender. Please note that on validation, we got this right every time. The reason for this is that we aren't just measuring, like with counting, if we see pieces of Y chromosome floating around in the maternal system. We have approximately 400 of these SNPs that we can interrogate, that we can look at. And if we know that the mother doesn't have any Y in her system, and there are all these SNPs floating around, it has to be coming from the pregnancy. And this is another important slide that shows very clearly, compared to non-SNP, whether it's Verify, Maternity 21, Harmony, or any variation that is not Panorama, you will have calls on gender that are incorrect. Again, this is country dependent. There are countries where gender is not part of non-invasive prenatal screening, where it is not called out, and of course Panorama abides by local laws. But for those where gender is called, this is truly important. The clinical experience goes on. That was a validation study. That was what happens in the lab. But what happens in real life? We followed up on tens of thousands of women to see if that superior false positive rate holds. And in fact, we were able to confirm in peer review the superiority of Panorama. So let's take a look. This is the paper from Dar et al. And Dr. Pierre Dar at Montefiore, New York, was the first author. The senior author, Dr. Peter Ben, who is well known as well in the prenatal screening community, looked at our data. And the important note here is that the false positive rate is very important when you calculate positive predictive value. And positive predictive value means, doctor, what is the chance that my fetus is affected? In other words, what we want to know is, out of all the women that go for amniocentesis, what percent actually have the problem we were looking for? And this is a value that is driven by the population prevalence, but very much by the false positive rate. Another way to say it, if you have the best false positive rate, that converts to the best positive predictive value, the chance of being positive on confirmatory testing. I'm very pleased to show you this slide today. And as you can see, overall, we had a combined 83%, but most important, Down syndrome is 91% positive predictive value. Trisomy 18, 93%. And as you can see, trisomy 13 and Turner syndrome, monosomy X, is approximately half, approximately 1 in 2, rather than over 9 in 10. Now, the reason that's happening is because we have data and very good, interesting literature that demonstrate that chromosome 21 and chromosome 18 in placenta is stable. It is far more likely to match with the fetus. Because 13 and Turner syndrome is more of an issue, when we look at the literature, there is a higher chance that the placenta will have monosomy X or trisomy 13 compared to a fetus. Has a higher rate of confined placental mosaicism for those disorders. So our literature matches out very nicely with the issue we spoke about earlier, confined placental mosaicism, which affects all pregnancy tests, all non-invasive tests. However, because we can deal so well with the other causes of false positive, we have superior positive predictive values, again, over 90%. And this was another very interesting finding from the paper. As you can see, we looked at low risk and high risk in the follow-up cases, and please note how many women were in each group. We looked at low risk based on age, and you can see there are definitely two very distinct groups. The positive call rate is only 1% using Panorama in low risk and only 2.4% in the high risk group. But look at the PPVs. They're very similar. This was surprising. We expected that the positive predictive value would actually be lower in the low-risk population. What happened? And Dr. Peter Ben, and it is in the, this is a possible hypothesis, but that as women age, we have pregnancies. There's a higher, as we know, a higher prevalence of aneuploidy, abnormal chromosomes, in the fetus or the newborn as the woman ages. The placenta as well may be more aneuploid or have a higher risk of aneuploidy. And confined placental mosaicism may be more of an issue in older women, and this test is used in an older high-risk population. When you're younger, you may have a lower incidence of these issues of confined placental mosaicism, less likely to have aneuploidy in the placenta, and the test actually may work very well for that reason in low risk. Now I'm going to wrap up the talk with a discussion on microdeletions. Where are we going? Because SNP technology, as you can see, we can look at very fine levels at the DNA. And if we can look at SNPs on chromosome 21, 13, 18, X, and Y, we can also look at those SNPs or those changes on a submicroscopic level. The reason we say submicroscopic is the way that routine karyotyping is done is using light microscopy. You actually look under a light microscope and you can see 46 pieces. Submicroscopic means that we can look at changes on an even finer level than that. And that's what we call microdeletions. So Panorama is the only peer review paper. It just came out in press recently, entitled Expanding the Scope of Non-Invasive Prenatal Testing, Detection of Fetal Microdeletion Syndromes, with the lead author, Ronald Wapner from Columbia. Many of you will recognize his name as being the lead author on the major paper on microarrays that came out not that long ago. And again, the only peer review looking at microdeletions. And what did we find? Again, excellent sensitivity and specificity. We look at 5 microdeletion syndromes currently based on severity and our ability to provide excellent sensitivity and specificity, and are relatively common enough so that we can determine positive predictive values that are overall very strong. And when we look at all these disorders, there's one that truly jumps out as being very meaningful for clinicians and patients alike. That's the 22q deletion syndrome. Some of you on the phone may know it as velocardiofacial syndrome, and DeGeorge is another name that it goes by. I'll be using 22q, but they really are referring to the same disorder. You can see excellent sensitivity and specificity for the deletion. And again, microdeletion means a small piece of chromosome is missing. It's not one gene that is missing, but it is several genes in succession that are missing. And in fact, you don't see them when you do routine karyotype. You do see them when you do microarray. And as we know, if you have a woman in your office, and I want to stress this, and I will stress this, if you have a woman in your office who is at high risk for microdeletion, or you do an ultrasound prenatally and you see a tetralogy of Fallot cardiac disorder or cardiac malformation, that woman needs to be offered invasive testing. However, these microdeletions can happen to anybody, and as you'll see in a moment, aren't based on age. And often, again, anybody who's been practicing for a long time will know these microdeletion syndromes can come out of nowhere with no warning. They are, again, a series of genes that are missing, not just one gene. 22q is a very classic example where you have multiple issues, again, based on multiple genes, and the embryology. The pharyngeal pouches do not develop normally. Again, as I mentioned before, well-known cardiovascular, tetralogy of Fallot. In fact, 10 to 15% is 22q when you see that on your prenatal sonogram. Endocrine features, extremely important. The parathyroid glands do not develop properly and therefore calcium issues. Thymic hypoplasia and aplasia, and you end up with immunologic problems, defects due to T-cell deficits. And 22q is important because it is the most common microdeletion syndrome with important perinatal significance. It's the second most common cause of congenital heart disease after Down syndrome, the second most common cause of major developmental disability after Down syndrome, and it is the most common cause of syndromic cleft palate. It has really major clinical impact on our practice and for our patients. And I mentioned before, it can come out of the blue. It is not age dependent. There is no real prior risk factor in a general population that we know of presently that we would know that, oh, this patient is at risk. Individuals can carry the 22q deletion and they can have children. In that case, there's a 50% chance they will pass along the microdeletion. But overall, in a low-risk population, there is no change with age, very different than aneuploidy. And in fact, there have been presentations to suggest that the incidence of 22q is more common prenatal than postnatal, which would make sense as pregnancy loss is associated with 22q. And the purpose of this slide is to drive home the message. If you're a younger woman, microdeletions, and especially 22q, may be more of an issue than the aneuploidy, than even Down syndrome. This slide brings home the same message. There's a lot of prenatal screening that goes around all over the world every single day, but after Down syndrome, it's 22q, and certainly far more common than trisomy 13 and trisomy 18, which we are screening for all the time. And there's another important distinction about 22q that is important for everybody to know. This is a paper from University of Toronto, which is in fact my alma mater where I got my training. But the important point of that is at University of Toronto is Dr. Ann Bassett, an expert in 22q who did a very important study. And what she looked at is children with seizures from hypocalcemia and because of 22q at birth. And what she was able to show is if you had these seizures at birth, you were more likely to have long-term disability related to cognition and cognitive function. So much so that there is a suggestion and recommendation here actually that these findings support the importance of early recognition and treatment of neonatal hypocalcemia and potentially neonatal screening, newborn screening for 22q, because you can impact the overall lifetime of a child with 22 deletion syndrome. So let's think about that and what it means, because it's actually quite profound. Early intervention matters, especially because these children are often missed in the nursery. They can be infected and they can be seizing, and nobody may know for a very long time. And in fact, the average age of diagnosis for 22q is 5 years of age. If you could know before delivery, what could you do? Here are the things you could do that matter. You could deliver the baby at a proper level 3 facility that has expertise in 22q. No live vaccines, because these children are immunocompromised, and in fact you can potentially cause real harm, if not death, if you give live vaccines, as we know, to immunocompromised individuals. Most important, watch calcium very carefully. And you can, if you keep calcium levels normal, you can avoid seizures and cognitive impairment. And also checking the palate to address malnutrition and speech development problems. Here's the message, and perhaps the most important message today. For the first time in prenatal history, and you can, or I should say prenatal screening history, by offering prenatal screening, you can affect the long-term outcome for the baby. In other words, what I'm suggesting here today is if a patient asks you, doctor, will this screening test help my baby? We can say yes. Prenatal screening has always been very important for managing the pregnancy. However, to actually make the statement that if I know ahead of time, especially for 22q, that might be an issue, you can impact the care over a lifetime. Again, this is the American guidelines, and I know I'm broadcasting overseas today. However, the consensus in the medical community is that if you are high risk for 22q, if you see congenital heart malformation or any other sign on ultrasound, for example, absent thymus, that really requires referral to fetal medicine center or expert for further consultation and discussion with the team, and possibly offering invasive testing to make the diagnosis in high risk. We're screening in low risk for microdeletions, and we were able, and this is again in the literature in our publication, but we actually can give a negative predictive value, a low risk report, such that if you get a negative 22q, we can say that negative screen, we can say there's a residual risk, a negative predictive value of approximately 1 in 13,000 for all 22q, not just for the deletion we measure, but we made the calculation to take into account all of 22q to make the counseling more easy for you in the office. And if it's a high-risk report, in other words, if we say this shows screen positive, it will say high risk in the report, and this is actually a picture of the report to make it as user-friendly as possible for the physician. And our positive predictive value is 1 in 19. In other words, out of 19 amniocentesis on follow-up, 1 will have 22q. And as you can see, we make the recommendation to refer for counseling and further follow-up and management. The reason the PPV is over 90% for 21, but 1 in 19 for 22q makes sense. In the case of 21, we have SNPs across an entire chromosome. For 22q, we have SNPs over a much smaller submicroscopic region, and the important point being that no positive predictive value on our Panorama test is worse or less than the traditional screening that those of us who are together today for the webinar use every single day. Remember my first slide, 5% is the positive predictive value of traditional screening, even in the best of hands. After an excellent first trimester screen, combined test, only 1 in 20 women will actually have the condition. So we set that as our bar. And I am so excited to share with you today our results. This is from the first 6 months. We've done many more since of 22q. Out of over 20,000 cases, 97 were positive. There were 2 maternal cases, 2 women who had 22q that did not necessarily know that they were that they had the mutation, and they were able to go for further follow-up. We had confirmation with cytogenetics for true positives and false positives, and we have no follow-up on only 5 overall of these 97. The rest are pending and carrying on to pregnancy, which is very important. You can see right away that in the case of 22q, women are going to carry their pregnancies to delivery, and therefore knowing and being able to advise the pediatricians become very important, and our positive predictive value is higher than we predicted. Our positive predictive value is running at 17.5%. That's 20%. So in fact, you can see right away from the numbers that if women elected, from what we now know of confirmed cases, 17%, that is not, that's not inconsequential. That actually is 1 in 5. So my last few slides here is to let you know that we provide really very thorough, deep clinical support to providers. We appreciate that this is very new, and it is important, and the discussion with the patient and how to explain to patients what non-invasive prenatal testing is all about is very important. We, in fact, have developed some tools that you can use in the office. So, for example, how do you counsel a patient who may be positive who may have a positive screening test? So you're here today because you've had a positive screening test for a chromosome problem. What does screening mean? Why am I here? You can make these discussions actually very simple. Screening means that the baby has a chance of having a problem. However, the screening test is not diagnostic. Again, there are options. How much do you have to explain pre-test counseling? You don't have to give an entire explanation of the human genome or even go into a lot of detail about the various chromosome abnormalities. What patients need to know is that DNA is the molecule of life. It's in all our cells. It controls our processes, biologic processes. DNA is so long that it's stored in packets called chromosomes. The number of chromosomes is important. The fact that each chromosome has so many genes. And if there are too few or too many chromosomes, a baby can have important problems. And even if a small piece of a chromosome is missing, for example, 22q, if important genes are missing, there can be a problem. We even have been developing an algorithm and a screening and diagnostic decision tree. If you, for example, come in because there's high risk from a first trimester test, you'll see here that women have three options: to do nothing on the left-hand side. If they want to know everything, then invasive testing and referral to fetal medicine on the right-hand side. Most women, however, will want a screening test. The middle box explains those disorders that can be detected, and 4 important points. These are the 4 points that if a woman understands, she really has informed consent, that this is a screening test only, that there are other things that can be screened for using invasive testing, that a low-risk result reduces the risk but doesn't take it away. A high-risk result needs confirmation, and regardless of the result, there's always a small chance of a birth defect, no matter how good a doctor one is and how careful a patient one is. There are genetic counseling resources available at the website, and also if you contact us, including fact sheets to help explain results. And in summary, Panorama technology can help distinguish pregnancy resulting in, by distinguishing the mother from the pregnancy, lower false positive rate, correct fetal sex calls when it's reported were allowed by law, only peer-reviewed microdeletion validation study, which was just released, and finally, you can improve the health of the newborn and child throughout a lifetime with well-validated 22q deletion syndrome screening testing. We are now at question and answer, and I just want to thank everybody for listening in. I believe we do have a few minutes for questions. And again, thank you so much for listening in today. And I'm going to turn it back over to Melissa.
Great. Thank you, Dr. Gross. That was a fantastic presentation. If you do have a question, please feel free to click on the Q&A tab on the bottom of your screen and submit it. We do have questions so far. The first question is just clarifying that if Panorama detects an abnormality, does that mean that the baby already has the disease? So can you just go into a little bit of detail about what should happen if Panorama is high risk?
So that is that's a very, very important point. And if Panorama is high risk, the most important messaging to the patient is that this is not a diagnostic test. And that was why I stressed in the presentation that this test, all the tests aren't actually looking at mostly fetal DNA. It's looking mostly at placental DNA. And the way to explain this very simply to a patient is that using Panorama, a very high percent of the time, we know in biology that the placenta matches the fetus, matches the pregnancy, but not always. If you have a Panorama test over 90% of the time, at least 9 in 10 of the time that we do an amniocentesis, the problem is there. But a few percent points of the time, the baby will come out normal. And that, we believe, is the reason why. Because the test for Panorama was picking up DNA from the placenta, and it didn't match up correctly or perfectly with the fetus. It is therefore extremely important. And again, that's the counseling. There is a small chance that the placenta, the pregnancy don't match, and therefore confirmation or offering confirmatory testing with an amniocentesis is necessary. And also, of course, at that point, referral to an expert center who can offer invasive testing, and also always sonography in good hands can help you give more clues as well. As we know, there's certain findings associated with Down syndrome, with 13 and 18 especially. Would you like to add anything to that, Melissa?
No, I think that was a very appropriate answer, so thank you. We have one more question. The question is just, can you talk a little bit about how you screen for microdeletions using SNPs and how that compares to how we screen for aneuploidy?
The idea is, because these SNPs happen every few hundred times in our genetic code, we can pick the SNPs we want to look at. In aneuploidy, there are more SNPs because we can look at the SNPs across an entire chromosome. So we have more data for the algorithm for the computer to look at. In the case of 22q, the concept is exactly the same. There are fewer SNPs, but again, we put on microdeletions that we are confident that we can call, that we have sufficient information to give you a reliable result. So the concept is the same. With SNPs, you can look anywhere that you choose to look. We looked at those areas that we feel very important. Again, the pretest counseling is very similar. You say to the patient that you're here today. We have a test that is available that can screen. It's not a diagnostic, but it can help us potentially identify pregnancies at risk for chromosomal problems. Some chromosome problems are over the entire chromosome, and some of the problems are to a smaller piece of the chromosome. And that was the slide that I had showed previously. If you look at the bottom bullets, it explains the pretest counseling. We have 46 chromosomes. If we have extra chromosomes, we can have hundreds and thousands of extra genes. If we have a small piece of chromosome, it may only be 10 genes, but if those are 10 important genes, there can be a problem. So that is, the difference is just the real estate is the way to say it, the amount of chromosome you're looking at, but the idea is the same. And again, if in that region you have important genes, then you can actually have a newborn who is sicker than a child who has extra chromosome 21, many of whom do very well. So bad microdeletion syndrome can actually be worse. It's just that the genes involved are so severe and so important when they're absent. Any other questions as we come to the top of the hour? Well, with that, we're now at the top of the hour. I have the privilege and the pleasure to thank you again. Of course, you may have more questions. We could not get to all of them. Please feel free to contact us, and you can see Judy Wang, who represents our company, who absolute privilege to work with as well. Any questions, Judy will be more than happy to help you with them or direct them to the person who can. Our website has a lot of information as well. And again, the most important thing I'd like to stress is that everything is all about the patient. It's providing the best care that we can, and we're there to help with the counseling and the information piece. And we can absolutely provide guidance and materials and information as well so that we provide the best and safest care possible. Thank you, and thank you for listening in.